Lance Armstrong's team of engineers used mathematical equations, i.e. functions, to help them determine the design of his bikes and helmets. Many of these functions must be combined together in order to maximize the results. Hi, my name is Tom Atwater, and we will be investigating just that, how functions are combined mathematically. Let's start by defining the four basic operations with functions. Operations on functions. Given two functions, f and g, for all values of x for which both f of x and g of x are defined, the functions f plus g, f minus g, f times g, and f divided by g are defined as follows. For the sum, f plus g of x is equal to f of x plus g of x. For the difference, f minus g of x is equal to f of x minus g of x. For the product, f times g of x is equal to f of x times g of x. And for the quotient, f divided by g of x is equal to f of x divided by g of x, provided that g of x does not equal 0. Okay, so the domains for f of and g, when you combine them into f plus g, f minus g, f times g, and f divided by g, are all the intersections of the individual domains of f and g. But again, for f divided by g, g cannot be equal to 0. Let's take a look at an example. Let f of x equal x squared plus 1 and g of x equal 3x plus 5, and perform the following operations. Let us take them one at a time, starting with a. A is f plus g of 1. B, we're going to find f minus g of negative 3. And C, f times g of 5. And finally, D, f divided by g of 0. Okay, so let's start with the first one, f plus g of 1. All right, so we need to add together the two functions f plus g, and we're evaluating what is equal to 1. So this is going to be equal to f of 1 plus g of 1. So f of 1 is equal to 1 squared plus 1. Then we add g of 1, and g of 1 is going to be 3 times 1 plus 5. And that's going to be equal to 1 squared is 1, plus 1 is 2, plus 3 times 1 is 3, so 2 plus 3 gives us 5 plus 5, so that's equal to 10. Now let's take f minus g of negative 3. This time that's equal to f of negative 3 minus g of negative 3. Let's evaluate each of those functions and find out their difference. So take f of negative 3, and that's going to be negative 3 squared plus 1, minus, and I'm going to put parentheses here to show that we're going to have to subtract all of g of negative 3. And that's going to be 3 times negative 3 plus 5. Close the parentheses. This is going to be equal to negative 3 squared is going to be positive 9 plus 1 is 10. Then subtract off what's in the parentheses. So 3 times negative 3 gives us negative 9 plus 5 gives us negative 4. 10 minus a negative 4 is really 10 plus 4, and so that answer is 14. Now let's take f times g of 5. That's going to be equal to f of 5 times g of 5. So now we need to evaluate each of those f of 5 and g of 5 and then multiply them together. So for f of 5, we would have 5 squared plus 1. I'm going to put that in parentheses to show that we're going to multiply that times all of g of 5. And g of 5 would be 3 times 5 plus 5. So we get 5 squared is 25 plus 1 is 26. We're going to multiply that times 3 times 5 for 15 plus 5 for 20. And that gives us an answer of 520. So next we need to do f divided by g of 0. So that's equal to f of 0 divided by g of 0. And that's equal to f of 0 on the top in the numerator. That's 0 squared plus 1. G of 0 in the denominator is 3 times 0 plus 5. Well, 0 squared plus 1, of course, is 1. 3 times 0 for 0 plus 5 is 5. So that's equal to 1/5. So here's the software that we use to emulate a graphing calculator. It emulates both the TI-84 Plus and the TI-83 Plus. I'm going to show you that this window here on your graphing calculator is going to be displayed here. And off to the right-hand side are all of the different key punches that we're going to do in order to do this example. So on your keypad, we're going to start by hitting the equation key, or what's called the y equals x key, which will bring up this. I need to clear off that equation, and then we're going to enter the x followed by squared plus 1. And of course, this represents for us f of x, which is x squared plus 1. Let's move down to the y sub 2 equation. Let's clear out that equation and now enter into the number 3 followed by x plus 5, and that gives us g of x. Then we're going to enter into the second key followed by the mode so that we get back to this screen. Then we're going to clear that screen, which is done, hit the variables key, move over to the y variables, hit the enter key, and then the enter key a second time, which gives us y sub 1. Now, we're going to use this as a function, so we need parentheses, the number 1, followed by parentheses. So we're taking y sub 1 of 1. Remember, y sub 1 is f of x, so we're looking for f of 1. Then we need to add to that g of 1. So now we need to get y2 there, so we hit the variables key, we move over to the y variables, we hit the enter key for functions, and now we need to move down to y sub 2. Then we can hit the enter key, which brings that up, followed by parenthesis with the number 1 and the close parentheses. So this is the equivalent of f of 1 plus g of 1. When we hit the enter key, it yields 10. Let's do part B. You want to hit your variables key, then you want to hit the right key to move over to y variables, hit enter for function. We want y sub 1, so hit enter again. And now we need to enter the parenthesis, the negative symbol, and make sure you use negative, not the subtraction. Then the 3 key, the parenthesis key. The subtraction key, followed by variables, and we want the y variables, so move over to y variables. We want the functions, and this time we want y sub 2, so you need to move down. Now you can hit your enter key, and we need to enter the parentheses, the negative key, the 3, the parentheses, and this time when we hit enter, we get 14. Then we need to do part C, which is f times g of 5. So the variables key, the y variables, function, we want y sub 1, and then parentheses, 5, close the parentheses, then we're going to multiply that times, and we need to call up y sub 2, so we go variables, y variables, the function, hit the enter key. We want y sub 2 this time, so move down 1, hit the enter key, then the parenthesis key, 5, parenthesis key to close them, and then when you hit the enter key, it comes up with 520. And the last problem was f divided by g of 0. So hit your variables key, move over 1 to the y variables, the enter key for functions, the enter key for y sub 1, parenthesis, 0, close parenthesis, divided by key, then hit variables, move over to y variables, hit the enter key for function, move down to y sub 2, hit the enter key, parenthesis key, 0, parenthesis key, and this time when you hit enter, you come up with 1/5, which as a decimal is 0.2. Well, let's do another example, and this time we are going to do it for operations with just a general function. We won't have specific values for x. So let's take a look at this example. We have f of x is equal to 8x minus 9, and g of x is equal to the square root of quantity 2x minus 1. Perform the following operations and state the domain. We have a, which is f minus g of x, and we have b, which is f divided by g of x. So the first thing that I want to do is write down the two functions we're dealing with. F of x equals 8x minus 9, and g of x equals the square root of quantity 2x minus 1. So here we go, f of x. And that's going to be equal to 8x minus 9. G of x is going to be equal to the square root of the quantity 2x minus 1. And the first thing we want to find is f minus g of x. And remember, that's f of x minus g of x. So in this case, we take f of x, 8x minus 9, and we subtract g of x, which is the square root of quantity 2x minus 1. And that's our answer for f minus g of x. Now we want f of g divided by x for part B. So we have f of g f divided by g of x. That's going to equal f of x divided by g of x. So we have f of x, remember, 8x minus 9. And that's going to be divided by g of x, 2x minus 1, quantity underneath the radical square root symbol. So that's f divided by g of x. All right, that was operations of functions with just the general. Now, in terms of the domains, we need to talk about the domains of each of these functions. And remember, we said that you look at the individual functions to help you determine that. When we look at the domain here, what we need to remember is that, we cannot have 0 in the denominator, because 0 in the denominator would then be undefined. So we look at the fact that this whole square root has to be greater than 0, which means that 2x minus 1 has to be greater than 0. So that's 2x is greater than 1, x has got to be greater than 1/2. Okay, so that tells us our lower limit, x, is greater than 1/2, and so our domain, it can't include x, so we use the open parenthesis, and it's going to then go all the way to infinity, which again, we use the open parenthesis for infinity. So that's the domain of this particular f divided by g of x. Okay, next what I'd like to do with you is to talk to you about something called the difference quotient. The difference quotient is this. You have a graph in which we have a curve. We don't have the entire curve, but we have this curve here, which we're looking at. That's our y equals f of x. It's a portion of y equals f of x. Then we have what's called a secant line right here, in which we have two specific points. We have point P, which is x comma f of x, and then we add h to x, which moves it over to here, and then we have a second point q, which is equal to x plus h, comma, of course, f of x plus h. When we look at the slope of this secant line, the slope, which we symbolize with the letter m, would be equal to the y value, f of x plus h here, minus the y value of point P, that's here, minus f of x, over the x value, x plus h, minus the x value of P, which is just minus x. And if we simplify the denominator, we will see that the x's cancel each other out, and we have in the denominator h, the numerator remains the same. Let's do an example. Let f of x equal 2x squared minus 3x. Find the difference quotient and simplify. So the difference quotient is f of x plus h minus f of x all over h. And the function that we are going to apply is f of x is equal to 2x squared minus 3x. So we're going to substitute x plus h in place of x. So we have 2 times x plus h squared minus 3 times x plus h. And now we need to subtract just f of x, which would be 2x squared minus 3x. That is all over h. Now we need to simplify our difference quotient. So we have equals to 2. X plus h squared would be x squared plus 2xh plus h squared. Then distribute the negative 3, and we get negative 3x minus 3h. Distribute the minus sign, we get minus 2x squared plus 3x. That is all over h. We need to distribute the 2 inside here, so we get 2x squared plus 4xh plus 2h squared. Then we still have our minus 3x minus 3h minus 2x squared plus 3x. That's all over h. Well, now we can look to see what things can be combined. And we see that we have a 2x squared and a negative 2x squared, so they add up to 0. 4xh, there's no like term to 4xh, so I'll write that down. Then we have plus 2h squared, which there's no like term for that. And then we have negative 3x, for which we also have positive 3x, so they will add up to 0. We have minus 3h, and that's all over h. Each of these terms includes a factor of h, which means that we can factor out the h and then cancel it, and that's going to leave us with 4x plus 2h plus 3. I'm sorry, minus 3. And that's the simplified form of applying the difference quotient to the original function f of x equals 2x squared minus 3x. Now, the difference quotient is essential to the definition of the derivative of a function in which you will study in calculus. Now, let's turn our attention to the composition of functions by looking at a diagram. I have in front of you two functions. We have f, which I've symbolized with this function box, and we're going to put into that x. And we'll do some manipulations to it, and then we're going to take the output, whatever that output is, and we're going to put it into a second function, g. And we're going to manipulate that, and it's going to give us an output, which is the equivalent of g of f of x. And in particular, if f and g are functions, then the composite function, or the composition of g and f, is defined by g composed with f of x is equal to g of f of x for all x in the domain of f such that f of x is in the domain of g. I think the best thing is for me to do an example for you so you can see the composition of functions. Here's an example. Let f of x equal 4x plus 1 and g of x equal 2x squared plus 5x, and we want to find g composed with f of x, which is equal to g of f of x. So what I should do is write down the two functions. F of x equals 4x plus 1, and g of x is equal to 2x squared plus 5x. What we're interested in finding again is g of f of x. And what that means is this. I want to take f of x, which is 4x plus 1, and I want to substitute f of x in place of x in the function g of x. So what that will look like is the 2, and then parentheses 4x plus 1 squared plus the 5, and then parentheses 4x plus 1. So now we need to simplify this, and we have the 2, and then 4x plus 1 squared. We expand that with 4x squared gives me 16x squared, plus twice the product of those two, 8x, plus 1. And then we can distribute the 5 inside of this parenthesis, gives us 20x plus 5. We now need to distribute the 2 into all three of those terms. So we get 32x squared plus 16x plus 2. Then there's plus 20x plus 5. The only squared term is right here, 32x squared. However, we have 16x and 20x, which gives me 36x. And we have a plus 2 plus 5 for plus 7. So the composition g of f of x is 32x squared plus 36x plus 7. Let's explore an example of the applications of operations in composition. A linear cost function has the form c of x equals mx plus b, where m represents the cost per item and b the fixed costs. The revenue function has the form r of x equals p times x, where p is the price per item and r of x is the revenue from the sale of x items. The profit function is given by p of x equals r of x minus c of x. I think the best thing to do is an example of this, so let's take this example. Suppose a business person invests $1,500 as the fixed cost in a new venture that produces and sells a device that makes programming a VCR easier. Each device sells for $100. Write a linear cost function using x as the number of devices produced. Write a revenue function if the device sells for $125. Write the profit function, and then calculate how many items must be produced and sold before the company makes a profit. Okay, so the important information from that slide is that there's fixed costs of $1,500 and that the price per item is $100 to manufacture it, but they sell it for $125. We start off with the cost function. Remember, the cost function, c of x, is a linear function, mx plus b. And in our example, we were told that b, the fixed cost, is $1,500, and that the price per item, m, in this case, was 100. So our function would look like this. C of x equals 100x plus 1,500. So that's the cost function. Next, we were asked to find or write a revenue function if each device sells for $125. So the revenue, remember, is also a linear function, p times x, and that's equal to 125x. 125 being the price of each that they sell it for. Next, we need to write the profit function. P of x is going to be equal to, remember, r of x minus c of x. And that means P of x is equal to, r of x we said was 125x, minus c of x, which is, in parentheses, 100x plus 1,500. We need to distribute the minus sign to both of those, and we will get a simplified profit function. 125x minus 100x is 25x. And then minus the 1,500. So that's our profit function. Now, the last thing they asked us to do was to calculate from the profit function how many of the devices had to be produced and sold for them to begin to make a profit. Well, what that means is that the profit has to be greater than 0. So we need to take this inequality and solve it. So it's 25x is greater than 1,500. So divide both sides by 25 and get x has got to be larger than 60. So what that means is that the company must produce at least 61 devices to start to make a profit. Well, now it's time for you to try a problem. Suppose that f of x is equal to x cubed and g of x is equal to x squared plus 3x minus 1. Find g composed with f of x. Pause the video to work on this problem. When you are finished, restart the video to check your solution. Let's find out how you did on that problem. Let me do it for you and see if you had the same answer that I get. So we had f of x is equal to x cubed, and we had that g of x was equal to x squared plus 3x minus 1. And we were asked to find g of f, or g of f of x. So what that means is we need to take f of x and substitute it in the place of x in the function g of x. So we take x cubed, and then we have to square that, plus 3 times x cubed minus 1. Remember that when you raise an exponential expression to another exponent, you multiply the powers. So this is x to the 6th plus 3x cubed minus 1. And that's the answer to the problem that you were to do. All right, great. Remember something, that when you take g of f of x, that's different from taking f of g of x. So be careful that you do them in the right order. So in this lesson, we explored the operations and composition of functions. Be sure to work the exercises that your teacher assigns, and we'll see you next time.